Okay, today we're going to go over section 7A. I've changed up the schedule a little bit. If you had looked at it before today for some reason, you would have seen that we're covering 4 sections before spring break, which is next week. Instead, we're going to just cover 2. We're going to cover 1 today, and then or 7A today, and then 7B on Wednesday. They're over probability. The chapter 7 is all about just probability, which is kind of a fun section actually. And we're going to get right into it. Give me just 1 second to get everything clicked on and saved. Okay, good. So let's get going. So today we're going to talk about probability and the fundamentals of probability. Your book kind of just goes over basic, it doesn't really define it per se, but it does start with outcome and events. So those are really what's important when you're talking about the probability of occurrence. So the outcomes are the most basic possible results of observation or experiments. For example, if you toss 2 coins, one possible outcome is heads, tails, right? And another outcome is tails, heads. So these are just all the outcomes that can occur. If you flipped 1 coin, it would just be heads or tails, right? A single event or a single outcome. But an event, though, consists of 1 or more outcomes that share a property of interest. For example, if you toss 2 coins and count the number of heads, the outcomes heads, tails, and tails, heads both represent the same number of heads. So it's a little different. The outcome is every single outcome that could happen with an experiment. An event, though, is built into those outcomes, right? So the book gives an example. It says, consider families of 2 children. List all the possible outcomes for the birth order of boys and girls. If we are only interested in the total number of boys in the family, what are the possible events? So let's just kind of break this down. We'll do this one with the document camera. Hold on. There we go. So if we've got a family with 2 kiddos and we want to know every single possible birth order, right? Well, they could have 2 boys, right? So first one's a boy, second one's a boy. And then we could do boy and then a girl, right? And then we could do girl and then a boy. And then 2 girls, right? These are all the outcomes if well, I mean, I know we can get into like different kinds of genders. We're not going to go there. Let's say gender's binary for this example. And we can either be a boy or girl. So you got boy, 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 girl, girl, boy, and girl, girl. Okay. Those are all the outcomes. The events, though, are a little different. So the book says, what if we're only interested in the total number of boys in the families? What are the possible events? Well, think of this as the number of boys to occur. Well, in this first example, we've got two boys occur, right? In the second example, we've got 1. I should say second outcome. Second outcome, we have 1 boy. Third outcome, we have 1 boy. It's the same. Fourth outcome, though, we have 0 boys, right? So this would be the event when you define the event as number of boys when you have 2 children, okay? The number of boys you could have if you have 2 children, 2, 1, 1, and 0, if gender is binary, okay? Then your book goes on. Let's do another one. Yeah, okay, find probability. Let's think about a single coin and assume that it is fair, meaning that it is equally likely to land on heads or tails. In everyday language, we say that the chance of a coin landing on heads on a single toss is 50-50, which means that we can expect the coin to land heads 50% of the time and tails 50% of the time. However, for the purposes of calculation, it is better to express the probability as a fraction. So let's talk a little bit about probability. If we use the letter P in this section specifically, we mean the probability of the event. Well, actually, probability. If we do P of E, this means the probability of E occurring. E, of course, could be anything. I just said it was a single event. So this means the language of this means the probability of E occurring. So instead of having to write all that out, we just say P of E, P parentheses E. No multiplication, just a notation thing. So if I flipped a coin, And I want to know what's the probability of heads. Now you can just write H if you want, that's fine. Or you could write the entire word, doesn't matter. So we'll say P of H2. These mean the same thing. Well, the probability of getting heads, we know, is 1 out of 2, right? It's 50. It's 50%. Oh, I wrote 1 up. 1 out of 2. 50%. Now, I'll tell you, with probability, we write probability as a decimal, okay? We write it as a decimal. We don't write it as a fraction. We don't write it as a percent. We write it as a decimal. It's a notation thing. I didn't come up with it. You know what? Your book writes it as fractions. Okay, decimal or fraction. Ugh, that's just this book. There's nothing wrong with that. We write it as a decimal or fraction. We're not going to write it as a percentile. So 1/2, which is just 50%, but also that means 0.5. Okay, 0.5. So we've got 1/2 chance. If it's a fair die, or not fair die, but a fair coin, we flip it. The probability of landing on heads is going to be 0.5. And we know the probability of landing on tails is also 0.5, right? Well, now one might ask, what's the probability of landing on heads or tails? Heads or tails? Well, no, these are the only two outcomes, right? The probability of landing on heads or tails would be 2 out of 2. So 1. Okay, and if you want to write it as 1.0, that's fine. It's 100%. If you toss a fair coin, the probability of landing on heads or tails is exactly 1. Excuse me. Tired. And so what happens is probability kind of lines up on this spectrum. And I'm going to go over this. It's in your book, but we're going to talk a little bit about it. Probability can only occur from 0 to 1, and we can include 0 and 1. Okay, 0 is that there's no chance of it happening. Okay, no chance of it happening. An example of 0 would be the probability of what's something that has no chance of occurring. I'll say today, the probability I wore a white shirt. Okay, white shirt. The probability I wore a white shirt today is 0 because I'm wearing a white shirt, right? Okay, I know that's subjective probability. We'll talk about that here in a minute. But it's a probability that there's no chance of occurring. Now, 1 would be it's certain. It's what's going to occur, no matter what. So the probability of the heads or tails is a good example. If you flip a coin, it's either going to line up on heads or tails. Halfway, 0.5 is that 50-50 chance. So 50-50 chance. And then look, as we go above 0.5, it becomes more certain of happening, right? If we go below 0.5, it's less of a chance of happening, okay? So probability, this is the probability line, or I'm not sure if they give it an actual name, but probability can only occur from 0 to 1. It's not greater than 1. It's not less than 2. So it's not negative, and it's not greater than 1. Because think about this. This is just percentages, right? 0% chance, 100% chance, okay? And the closer we get to 1, the more certain it's going to happen. The closer we get to 0, the less certain it's going to happen. Excuse me. Okay, and it's very, very straightforward on probability. Okay, that's the definition per se. How we kind of go over it. Yeah, and then your book then goes over theoretical probability. Did not go over the types of probability? I know it does. Hold on, give me a second. Okay, yeah, the first type of probability your book goes over is theoretical, which sounds fancy, but it's not. Okay, theoretical probability. And your book goes over 3 steps to find theoretical probability. It says, count the number of possible outcomes. Then step 2, among all the possible outcomes, count the number of ways the event of interest can occur. And then 3, determine the probability. Okay, so let's look. A die is a great example of this theoretical probability. Okay, this only works. I say it only works for the way they're going over it. It's only going to work if each outcome has the exact same chance of occurring. So let's think of a 6-sided die. Okay, a six-sided die. We've got, or we could roll a 1, 2, 3, 4, 5, and 6, right? We could roll a 1, 2, 3, 4, 5, 6. These are all of our outcomes, okay, from this experiment of rolling a six-sided die. So if I wanted to know the probability, the theoretical probability, excuse me, gosh, I don't know, I'm so tired. Let's say that we wanted the theoretical probability of rolling a 4. Okay. Well, we want to see how many ways can we roll a 4. Well, there's only one way we can roll a 4, right? There's only one chance of that occurring. And we've got 1, 2, 3, 4, 5, 6 outcomes. So therefore, the probability of rolling a 4 is 1 over 6. I'm going to leave this as a fraction because your book is okay with that. So we're just going to leave it. So the probability of rolling a 4 is just 1 out of 6. Let's look at something a little different. What about the probability of rolling an even? So we want to know the probability of rolling an even. Well, we need to look at all the ways we could get an even. I'll use a different color here. So we could roll a 2, we could roll a 4, and we could roll a 6, right? So we have 3 outcomes that could produce an even. But then we still have 6 outcomes, right? So it's 3 out of 6. Now, 3 out of 6 does simplify to 1/2. I'm going to write that one as 0.5. Why not? We've got a 50-50 chance, right, of rolling an even number because half of the numbers on our die are even. What about the probability of rolling a number? We'll use just the pound sign for number. A number greater than 4. The probability of rolling a number greater than 4. Well, let's see here. Numbers greater than 4. Well, the only 2 numbers that are greater than 4 are 5 and 6, right? So we have 2 numbers that are greater than 4. We still have just 6 outcomes, right? So therefore, this would be 1/3. We've got a 1/3 chance of rolling a number greater than 4. So if we're playing some game and the objective is to roll a number greater than 4, well, we know we've got a 1/3 chance of doing that. Okay, this is where that comes from. So now let's look at, because I'm probably going to use this example moving forward, so I'm going to stick to it a little bit. Let's draw from a deck of cards. And if you are not familiar with a deck of cards, that's fine. I'm going to go over it a little bit. There's 52 cards total. We're not playing with jokers or anything weird like that. Okay, 52 cards total. 4 suits. We've got, hearts. We've got diamonds. We've got spades. And then we have clubs, right? I can't remember if it's 3 or 4. It's 3. Okay. That's fine. We've got 4 suits, hearts. You know what? Just because I can. Hearts, diamonds, spades, and clubs. And also, look, hearts and diamonds are red. Spades and clubs are black. Okay, so then how many are in each suit? Well, there's 13 cards because 13 times 4 is 12. So 13 cards in each suit. And they go from really 2. Here, let's say 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got the Jack, King. Oh, I did this out of order. Jack, King, Queen, and Ace. I ran out of room here. So it really goes through 2 through 10, and then Jack, Queen, King, and Ace. 1, 2, 8, 9, 10, 11, 12, 13, right? So 2 through 10, and then Jack, Queen, King, Ace. Jack, Queen, King, Ace. Okay, great. So now what if we wanted to find probabilities of this? Like, let's say I wanted to find the probability of drawing the ace of spades, right? the ace of, well, there's only one ace of spades, right? We got the suit is spades, and we're choosing the ace from it. So there's only one outcome where this can occur. We said there's 52 cards total, so 52. And just because I'm interested, I don't know, what is 1 out of 52? What's the probability that we got this ace of spades? Oh, 0.0, I'm going to round here, 0.019, we'll round it to 4 decimal places, 0.019. So about 1.9%, right, chance of drawing the ace of spades. Actually, 1.9 chance of drawing any single card, right? It doesn't have to be the ace of spades. It could have been the 4 of hearts or the 10 of diamonds. It doesn't matter. For any single card, it's going to be 1 out of 52. Well, what if you're playing a game with your buddy and the goal is to draw a heart? Like, you win if you draw a heart. You got these 52 cards that are all shuffled together, and you want to know what's the probability of you drawing a heart. Well, let's think about this. There's only 4 suits, right? So that means there's 13 hearts, right? If there's 4 suits, and we know that one of those suits is hearts, we know there's 13 in each suit. So I know there's 13 out of 52. 13 out of 52 of those cards are going to be hearts. So that actually simplifies to 1/4 because it's 1 out of 4 suits. 0.25. I got a 25% chance of drawing a heart. Kind of neat. Okay. What about the probability of drawing a red card? The probability, now look, red cards, remember, hearts and diamonds are both red. Spades and clubs are black. So that means half the deck here is going to be red. Now I'm going to do this though with each outcome. I know there's 13 hearts and 13 diamonds. So that's 26 cards that are red. And there's 52 cards total. Well, 26 out of 52 is 1/2. That's 0.5. Okay. Kind of neat. Kind of neat. Okay. Yeah. Okay. Great. Let's look at another example here. Your book goes over. The book says, what is the probability that a randomly selected family with 3 children has 2 boys and 1 girl? Assume boys and girls are equally likely. So we've got 3 children here. We need to talk about all the different ways we could have 3 kids, right? We could have, so we've got 3 kids. What's the probability we have, was it 2 girls? 2 boys. 2 boys and 1 girl. Okay. So let's think all the ways we could have 3 kiddos. Well, we could have 3 boys. We could have 2 boys and a girl. We could have a boy and a girl and a girl. A boy and a girl and a boy, right? So all the ways, if your first kid was a boy, I think that's right. And then we could have 3 girls, right? We could have 2 girls and a boy. We could have a girl, 2 boys. We could have a girl, a boy, and a girl. I think these are all the different ways you could have kids if you have 3 kids, okay? 1, 2, 3, 4, 5, 6, 7, 8. Now the question though, what's the probability that you have 2 boys and a girl? So let's look and see which of these have 2 boys and 1 girl. Well, we got 2 boys and 1 girl here. We got 2 boys and 1 girl here. But we got 2 boys and 1 girl here, right? So we got 3 different ways we can have this. Now, in total, though, we have 1, 2, 3, 4, 5, 6, 7, 8. So the probability of 2 boys and 1 girl would be 3 out of 8. Okay, which turns out to be, I think that's like point something or another. It's always point something or another in probability. 0.375. A 0.375. So kind of neat. Kind of cool. Okay. Yeah. So, and then the book goes over relative frequency probabilities on the next. This is on page 416 if you're following along in the book, page 416. And it talks about like repeated observation. It says the second way to determine probability is to approximate the probability. So remember we talked about theoretical. This is an example of theoretical probability. The next is relative frequency probability. This is also called the empirical method, which is what it's typically called in stats. So we'll say relative frequency method. Typically, it's called the empirical method. Empirical method. And it's when you just observe occurrences. So it's really kind of based on 416. It says repeat or observe a process many times. Who is calling me? How do I cancel it? Repeat or observe a process many times and count the number of times the event of interest A occurs. Estimate probability of A by given the number of times that occurs over the total number of occurrences. So this is like sports statistics. This is how sports statistics are given. So what they do is they look at the number of times. Let's look at like an interception rate. Okay. Let's do, why not? Let's do Pat Mahomes. Pat Mahomes statistics 20. We'll do the 2020 season. Not sure if I can easily find it. Oh yeah, here we go. For his 2020 season, he threw the ball 580 times for Mahomes. He threw the ball. So actually, let's say throw. Let's say he had 588 attempts. Okay. And we had 6 interceptions. So 588 attempts over 6 interceptions. That means his probability of interception, we're going to say is 6 out of 588, right? This would be a relative frequency probability. So 6 out of 588. Now I'm going to just look on my phone and do that real fast. So 6 divided by 588. That's 0.0102. You got a better chance of drawing the ace of spades. Okay, so 0.0102 for the probability of Patrick Mahomes throwing an interception. And all you're doing is, hey, look, there were 588 times it occurred. He threw the ball. Actually, not that it occurred. 588 times it could have occurred. And only 6 times did we have the actual interception. Okay, 6 times we had the interception. Your book goes over an example with like flooding. And it talks about, geological records indicate that a river is crested above a certain flood stage 4 times in the past 500 years, or 2,000 years. So 4 times out of 2,000. So 1 out of 500. It's 500-year flood. Okay. So same kind of thing. The relative frequency rate is just counting it up, the number of times it could occur or did occur out of the number of times it could have occurred. Okay. And the last one is subjective probability. Now, subjective probability is an estimate based on experience or intuition. And I'll tell you a basic example for me of subjective probability. In my college algebra class, when I give the first test, now I could actually find this, it's fine, but I can kind of estimate that the people that pass test one in college algebra, the probability of passing test 1 in college algebra is about 60%. Okay, shouldn't write as a percent, right? 0.60. And that's just subjective. I mean, it's just purely subjective. Okay, purely subjective. Okay, now let's look at the probability of an event not occurring. Probability of an event not occurring. Now, to find the probability of an event not occurring, you just do 1 minus the probability of it occurring. Now, I'm going to use a notation that I don't see in your book, but it's very common to use for this example. And it's just going to make it shorthand for me, so that's why we're going to do it. You use the probability, like if you want the probability of A not occurring, you can use a little line over it, okay? This means the probability of an event A not occurring. And to find the probability of A not occurring, it's 1 minus the probability of A occurring, okay? 1 minus the probability of A occurring. It kind of makes sense here. Let's go back to the card examples, right? If I want the probability of not, I'm going to write this all up, not drawing the ace of spades. If I want the probability of not drawing the ace of spades, okay, this is going to be equal to 1 minus the probability of drawing. I'm just going to draw the ace of spades up, okay? So this would be 1 minus. Now remember, we found this was 1 out of 52. Now look, 1 minus 52. Now if you're not comfortable with fractions, we have to get common denominators. So 52 out of 52 minus 1 out of 52. So 51 out of 52. This makes sense because there's 51 cards that are not the ace of spades. So the probability of not drawing the ace of spades would be 51 out of 52. Now, just because I want a number attached to this, I'm going to do 51 divided by 52. And we wind up with 0.9808 if we round, okay? So the probability of not drawing the ace of spades is 0.9808. But you can find the probability of not as 1 minus the probability of A, okay? Let's look at another example. Let's say the probability of not rolling a 4. The probability of not rolling a 4. Well, the probability of not rolling a 4, see how I use that notation, the probability for not 4, you just use a line over it. It's going to equal 1 minus the probability of rolling a 4. Well, we know the probability of rolling a 4 is 1 out of 6, right? I mean, this is on a die, I should say, a 6-sided die. The probability of rolling a 4 would be 1 out of 6. So it's 1 minus 1/6. Well, that's 5/6. And that winds up being, actually, let's leave it as 5/6 because it's a goofy decimal. Okay. So what about the probability of Mahomes not throwing an interception? The probability of Mahomes not throwing an interception. So now we're going to do INT, but not throwing an INT. Well, it's 1 minus the probability of him actually throwing the interception. Now we found that, I'm going to just use the decimal that we found. Actually, over here. It was 0.0102. So that winds up being 0.98 something or another. Clear. 1 minus 0.0102, 0.9898. So like 98.98% chance he doesn't throw an INT. Okay? That he does. Now he could throw other things, right? He could throw an incompletion. He could throw incompletion. He could throw a completed pass, but he's not throwing an INT. Okay? He's not throwing an interception. Then next, your book goes over really creating the probability distribution. It says a probability distribution represents the probabilities of all possible events of interest. To make a table of probability distributions, 1, lists all possible outcomes. 2, identify outcomes that represent the same event. And then make a table in which one column lists each event and another column lists each probability. Okay, yeah. Your book does this for, was it tossing 3? Make a probability distribution for the number of heads that occur when 3 coins are tossed. So 3 coins are tossed. And we want the probability distribution for the number of heads. The probability distribution number heads. So let's go through this again. If we toss 3 coins, we'll write all these out. We want the probability distribution for the number of heads on each coin. Okay, so let's toss 3 coins. Okay, we could get all heads, right? That would be pretty hard, pretty rare. We could get 2 heads and a tail, right? We could get a head and then 2 tails. Or we could get heads, tails, heads, right? That's everything that could happen when you toss 3 coins and the first one's heads. Now, what if the second one says we get to get 3 tails? We get to get tails, tails, heads. We get tails, heads, heads. Or we get tails, heads, tails. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. These are all 8 outcomes that could occur when you toss 3 coins. And if you look, it's exactly the same with the whole boy-girl outcome with 3 kiddos, because each one of these has the same exact probability of happening of 0.5, right? So therefore, it's the same exact probability. Now, we're looking, though, for the probability distribution for number of heads. So I'm going to write underneath here number of heads for each outcome. Okay, I'll write this in red. So if we look at this first outcome, we've got 3 heads, right? The second outcome, we have 2. The third outcome, we have 1. The fourth outcome, we have 2 heads. This one, we have 0 heads, right? This one, we have 1, 2, and 1. Okay? So this is just the number of heads. So now I'm going to actually make our distribution, or the way your book talks about distribution. And it talks about results here, and then the probability of it occurring here. Probability. Oh, Lord. I've spelled that so wrong. Probability. So now let's see what all could happen. We could have 3 heads, right? That occurs 1 time here, right? The 3 only occurs once. So it's 1 out of 8, right? We have 1, 2, 3, 4, 5, 6, 7, 8 occurrences. We have 1 out of 8. We could get 2 heads, which is probably might be the most common. Let's see, 1, 2, 3, 3 out of 8. We could have 1 head. 1, 2. Oh no, it's also 3 out of 8. And we could have no heads, right? We know that it happens once here. So 1 out of 8. So here is the probability distribution for the number of heads. Honestly, it could be number of tails too, but number of heads if 3 coins are tossed. And notice when you add up all these probabilities, you get 8 out of 8. You get 1. Okay, if you added up the probability column, everything that occurs happens right here. So therefore, we get 1. Okay, when we toss 3 coins, these are the 4 options that could happen. If we want to go back to what we were talking about, like the probability of 3 heads would be 1 out of 8, right? The probability of 1 head would be 3 out of 8, right? That's the old stuff. Now they're just combining, well, what happens, what's every possible outcome in this scenario? And what we've done is we've created a probability distribution. Kind of cool. Okay. Now the last topic in this section goes over odds. Odds for and odds against. So if you haven't heard of odds before, it's another way of writing probability or thinking of probability. It's just typically kind of the real world way of thinking it. So the odds for an event. So odds for event A. It's just written different. It's not probability. It's odds. Now, I say it is probability. They're similar. They're tied together. Odds are just different. So odds for A. The way you would write this is the probability of A over the probability of not A, okay? The probability of A over the probability of not A. So if we wanted the odds to roll a 4 on a 6-sided die, it's not 1 out of 6. That's its probability of being rolled. So if I want the odds, it would be the probability of rolling a 4 over the probability of not rolling a 4. Well, we know the probability of rolling a 4 is 1 out of 6, right? And remember earlier, the probability of not rolling a 4, that's 1, 2, 3, 5, and 6. So that's 5 out of 6. Now, if you simplify these, if you divide a fraction by a fraction, it's actually 1/6 times, and you flip the bottom fraction. So 6 out of 5. 6's cancel. You wind up with 1 out of 5. And it's not 1 out of 5. It's actually, we say this as 1 to 5. We got 1 to 5 odds. 1 to 5 odds. And what that means is we think if the total is 6 rolls, we think one of those rolls is going to be a 4 and the other 5 are not. Okay, so if you hear 1 to 5 odds, that's what that's talking about. It's not 1 out of 5, because really the probability of rolling a 4 is 1 out of 6, right? It actually is telling you the number of occurrences we should have and the number of occurrences we shouldn't have, okay? Then your book just does odds against. Against, which would be the probability of against over the probability of it occurring, okay? So if we wanted to look at I'm sorry, I can't talk right now. The probability of not rolling, the odds against rolling a 4, well, it would be not 4 over 4. So it's going to be 5 over 6 over 1 over 6. Now this winds up being 5 to 1. 5 to 1 odds of not rolling a 4. Okay? 5 to 1 odds of not rolling a 4. Okay, great. So for homework in this section, we're going to stick to what the book went over here today, or what the book states. The book says let's do 1 through 83 odd. You can do 1 through 79 and really understand what's going on, but 1 through 83 odd. Some of these will be real quick to do. They'll take just a few seconds actually, and some will take a little bit longer, but I would definitely make sure to do the homework. That way you really understand this concept of probability. Okay, great. I'm going to